of any of these guys on the periodic table, if I want to weigh out a mole of something, say I want to weigh out a mole of sodium. Oh, smart ones in the classroom, tell me how many grams of sodium I need to put in my solution to have a mole of sodium. 22.99 grams. That would give me how many molecules or atoms of that substance in my mixture, which is, there you go. You're wicked smart too. So that mass relates to this number. So if I have to make a 1 molar solution of sodium chloride, now I'm going to throw a little monkey wrench in there. Sodium chloride. What's sodium chloride's formula? NaCl. And what does that mean? One sodium for every one chlorine makes that molecule sodium chloride. What if I needed 2 sodiums for every chlorine? What would my formula look like? It would say Na2Cl, like water. If I want to write water, what's water? H2O, right? Oh, I don't know how to use this stupid thing. We're not going to use it today. Something is not going correctly. Oh, here we go. So if I write this, oh. All right, I don't know why this is doing this. God bless technology. It won't let me pick my pen. All right, if I wrote H2O, what does that mean? It's water, but what does it mean molecularly? I have 2 hydrogens and 1 oxygen. Now, how much would I have to weigh out of H2O to give me 1 mole of H2O? How do you do that? I'd have to take 2 of the hydrogen atoms, which are 1.0079 times 2, plus what? Plus oxygen, which is 15.999. So about what? How many grams of water would I need to make 1 mole of water? Give me a guesstimate.
18 plus.
Yeah. So 16, 17, 18-ish. Yes? So if I weigh out 18-ish grams of water, how many molecules of water do I have in that 18 grams? 6.02 times 10 to the 23rd. So when you're making solutions and you need to be specific about how much or how many molecules I need in a solution, we can use molarity, and the molecular weight is going to directly correlate to the molarity of my solution. So if I took my 18-ish grams of water and made a solution, which I usually put in water, so water's not a good example. Say I want to make a 1 molar solution of sodium, which would probably explode, but pretend it wouldn't. Sodium. How many grams of sodium would I need in 1 liter of water to have a 1 molar solution of sodium? Look on the periodic table. Go find sodium. How many grams of sodium would I need in 1 liter of water to make a 1 molar solution of sodium? I'd need 22.99. Yes? Okay, everybody understand that? So you take the mass, the molecular, what's that called? underneath the element? The atomic mass. And that's going to tell me how many in 1 mole grams I need to put into my solution. Okay, I'm going to ask you one more trick question. Sodium chloride. If I want to make a solution, a 1 molar solution in 1 liter of water of sodium chloride, what would I have to do? Take 22.999 and add it to what? 35.453. Anybody have a calculator? Can do math quick? You add the two together. What is it? Say 58. 58's good, ish. So how would I make a 1 molar solution of sodium chloride? I would have to weigh out what? 58 grams and put it into 1 liter of water-ish. Yes? And how many molecules-ish would I have of sodium chloride? 6.02 times 10 to the 23rd. Yes? So read that over a couple times and let it sink into the old noggin. They give us an example here of glucose. And in your book, this is on page 30. So glucose is C6H12O6. Holy moly, we're getting into some numbers now. Yes? So how would I figure out how many grams of glucose I need to put in a 1 liter solution to make a 1 molar solution of glucose? I'd have to take carbons. And where do they get the 6 from? Is it from the periodic table? Yeah, it's the subscript in front of the C. That tells me in glucose, how many carbons do I have? 6. I have to multiply that by the atomic number for carbon. And where did I get that? 12.011. That's coming off of this. Yes? And that gives me 72.066. I have to do the same for whatever, how many hydrogens there are, and in this molecule there happens to be how many hydrogens? 12. I multiply it by its mass, which is 1.008, and then oxygen. How many oxygens do I have in C6H12O6? 6. I have to multiply that by its atomic weight. So if I want to make a 1 molar solution of glucose, how many grams of glucose do I need to put in 1 liter? 180.156. And if I do that, how many molecules of glucose do I have in my solution? You got it. 6.02 times 10 to the 23rd molecules. Yes? Everybody good with that? So if it didn't click, go look at that again. Again, that's on page 30. That's the first couple paragraphs. So understand what molarity, a mole, and a molecular weight is. Yes?
So 2 moles would be the 180 times 2?
You got it.
Okay.
I might ask to make a 0.1 molar solution. So what we have to do?
Divide by 10?
Yep. Okay, and that's in 1 liter. What if I tell you I only want 500 milliliters? Oh! I just have to cut everything in half. Yes? So these numbers apply to 1 liter. If I only want to make up 250 milliliters, divide everything by what? 4. You see how that works? So you're going to use these numbers again in your life. You're going to use them if you need to go to chemistry class. And you might use them for sure if you have to make up solutions that you then have to administer to patients. So there's a little math involved in this whole profession. Yes? So that's one of the reasons why we get you, hopefully,